In this tutorial, we'll be discussing how to calculate solution concentrations. Solutions, by definition, are a homogeneous mixture, which means they're mixed evenly throughout the container. No matter where you look at the jar, it's going to have the same amount of particles, and that's what the definition of homogeneous means. The solvent is the majority component, while the solute is the minority. So in other words, you put the solute into the solvent. So if we were talking about salt water, salt would be the solute and water would be the solvent. Aqueous solutions are solutions in which the water specifically is the solvent. Now when we talk about solution concentrations, a dilute solution is a solution that contains a small amount of solute in relative to the solvent, where a concentrated solution contains a large amount. Molarity is a very common way to express solution concentration for chemists specifically. It's the amount of solute in moles divided by the amount of solution in liters. Note the word solution. That's the solute and the solvent added together. Be careful when it comes to that. So if it says 15 milliliters of ethanol and 35 milliliters of water, combined you have 50 milliliters solution. The grams over molar mass, you may remember, that's how we do moles. So whatever mass it is over 1, then the molar mass is on the bottom and 1 mole is on the top. You may remember that from previous tutorials. And then to get the molarity is the moles over the volume. So you have to figure out how many moles there are before you can calculate it. Now when we're trying to get a very specific concentration of a solution, we use something called a volumetric flask. Notice there's this little line right here. What happens is that is a very well calibrated line. That will be the exact volume to a 0.001 milliliters. They put the solvent in, then they add the solute and they stir it and mix it so that way it's evenly dispersed, and then they dilute it to that line to get a very specific concentration. So let's practice doing some of these molarity concentrations. We know that molarity, as we just learned, is moles over liters. So suppose you have 2.00 moles of a solute dissolved in 1 liter of solution. Look at that word again, solution. Most of the time with molarity, they'll give you the solution, but be cautious of that. So what is the molarity? So we know moles is equal to 2.00, and we know that liters is 1.00. So it's going to be 2.00 moles over 1.00 liters is equal to 2.00. Big M stands for molarity. So what if they give you grams to start with? Because you can't go to a scale and weigh out moles. You have to weigh out grams and then convert it to moles. Well, because of the grams, we know that as one of our key terms for molar mass, which means we need to look on the periodic table and add up those numbers. By doing so, you'll find that K is 39.10 grams per mole, and Br is 79.90 grams per mole. We can add those together to come up with 119.00 grams is equal to 1 mole. So we take 25.0 grams of KBr over 1. Grams are on top, so we need to put grams KBr on the bottom of the next line. That is 119.00. That's equal to 1 mole KBr. 0.210 moles. We can now put this into our equation of molarity, 0.210 moles. Another trick here, they gave us our volume in milliliters. It needs to be in liters. So 750 milliliters over 1, there's 1,000 milliliters in 1 liter. So that comes out to be 0.750 liters. That will be our bottom number of our molar calculation. And it comes out to be 0.280, big M for molarity. Let's try that again. In this question, 80 grams of glucose, and they actually give you the molar mass of glucose, is dissolved in enough water to make 1 liter of solution. So once again, the word solution, it's the solute and solvent added together. What's the molarity? So equation for molarity is moles over liters. We have the liters, we need to figure out the moles. We do that by using the 80 grams over 1 the molar mass goes on the bottom because grams are on top, so we need to put grams on the bottom. Your mass 180. Notice that decimal here, they're trying to make sure that you know that that 0 is significant. 1 mole C6H12O6. That comes out to be 0.444 moles, which means it's 0.444 moles over 1.00 liters, which comes out to be 0.444 molar solution. Let's take another look at this. A stock solution. Now we're talking about diluting the solutions. When you're diluting something, you're taking something that's rather concentrated, you're adding more solvent to it, and you're making the particles more spread out. A stock solution is something that you would literally have on the stock shelf. That's something that you have readily available. It typically is more concentrated because then you can dilute it and make a lot more of other things. And this is the equation to do this. M1V1 is equal to M2V2. So in other words, the concentrated solution, we need a small volume of that to make a weaker solution with a larger volume. And to give you a visual, notice we have all these particles and they're somewhat close together. Once we add more water and put it in a different jug, the molecules become more spread out. And that's what's happening when you're diluting. So, dilution practice. 53.4 milliliters of a 1.50 molar solution of NaCl is on hand. But you need 0.800 molar solution. How many milliliters can you make? Alright, notice the word of. That means that this and this are going to come together. They're going to stay together on the same side of the equation. So we have M1V1, M2V2. You know you're going to be doing a dilution because you have two different molarities here, one volume, and you need the other volume. The fact that you're going from a heavy concentration to a lighter concentration, that tells you you have a dilution. So the first molarity, the stock solution, is 1.50 molar, and it's 53.4 milliliters. We're trying to make 0.800 molar, and we're trying to figure out how many milliliters that is. We can actually keep it in milliliters because of the fact that it's asking for milliliters. The previous question didn't have anything to cancel out. It had to be in liters. But this time, since it's asking for milliliters, as long as the units are the same, you're okay. So 1.50 molar times 53.4 milliliters is equal to 0.800 molar times X. So you're going to multiply and then divide, and it comes out to be 100.125. We need 3 significant figures because all 3 of these numbers have 3 significant figures. So I'm going to put 100, and I'm going to put a decimal here so that way people know that those 2 zeros count. Milliliters. Let's try this again. 100 milliliters of, so these two things go together, 2.500 molar KBr solution is on hand. So that's going to be your stock solution. You need 0.5500 molar. What's the final volume? So M1 V1 M2 V2. 2.500 molar is our initial molar. 100.0 milliliters is our initial volume. We're getting 0.5500 molar, and we want to know the final volume. So let's put these numbers into our calculation. We're going to multiply 2.500 times 100 divided by 0.5500. That comes out to be 454.5 milliliters. Notice every single one of these has 4 significant digits, so I need to make sure I have 4 in my final answer. We'll do one more example before we're done. A stock solution of 1.00 molar NaCl is available. How many milliliters are needed to make 100 milliliters of 0.750? So M1 V1 M2 V2. So our stock solution is 1.00 molar. We're trying to find out how much we need. Our solution, the solution we're trying to make is 0.750 molar, and we need 100 milliliters of it. 100.0 milliliters. So we plug our numbers in. 1.00 molar times X is equal to 0.750 molar times 100.0 milliliters. Multiply 0.75 times 100 divided by 1, and it comes out to be 75 milliliters that we then dilute it and add enough water to make 100 milliliters. And that explains how to do both molarity and dilutions.